Good day, everyone. Welcome to exercise 2B, addition and subtraction of surds. Now, in the last lesson, you learned about what surds are. So say, for example, you have a square root of 5. If you pop that in on the calculator in itself, so square root of 5, you can see that this is a decimal 2.236067977, and it actually goes on and on and on and on and on. Right, so therefore, in terms of our surds as well, you don't get a whole number in itself. You don't get a terminating decimal. A surd is just categorized as an irrational number, and irrational numbers, you cannot express this as a fraction at all. Right, so knowing what our surds are, just going back to the slide over here, as we begin to add and subtract our surds as well, you can think of surds just like, I would say, like algebra. So when you add and subtract algebra, I'll just write that out here. Right, when you add or subtract that, you are actually looking for like terms. Like terms. Okay, how do you know what like terms are? So let's say, for example, if I have 7a, a like term to that is 5a, right? So basically, like terms for algebra, that is where you have the same letters, same pronumerals are in there to know that that they are alike, right? So let's say if you have 7a plus 5a plus 3z, right? So 7a and 5a are like terms, so therefore I can simplify that to 12a. Basically, what I've just done here, because it's addition, I'm just adding up my coefficients 7 and 5. That becomes 12, and a just follows after. Now, with your 3z, there is no other like terms for that, so we'll just add on 12 plus 3z at the back, right? So this will be our simplified version of this algebraic term here. Now, in terms of surds, right, we have square root of 5 over here. So what we call a like surd, it has to have that same surd together with that. So a like surd to square root of 5 could be 3 times square root of 5, or could be 5 times square root of 5, or it could be even 10 times square root of 5, right? Notice the similarities in terms of that square root of 5 happening for all of these surds over here. This is what categorizes them as your like surds. So the moment you have located that they are like surds, you can then begin to add and also subtract your like surds from there. Now, if we have the square root of 5 plus 4 times square root of 2, because square root of 5 and square root of 2 are unlike, right? We can call them unlike surds, so therefore we cannot add them together. Right, so just bear in mind that your condition for adding and subtracting surds, you need to ensure that you have identified your like surds. Now, knowing what like surd and an unlike surd is right now, we'll then put it into practice in terms of simplifying each surd first, right, before we begin to add and subtract surds. So I've jotted down a couple of steps here just to take you through the questions that you have under exercise 2B. Right, so in summary, you know what like surds are. So the first step, whenever you have addition and subtraction of surds, firstly, simplify each surd. So what I mean by simplify, you do need to ensure that your perfect squares are all outside the square in itself, right? Before you begin to look for like surds, reorganize your expression, and then after that, add and or subtract your like surds. Okay, so whichever that is. So it's add or subtract your like surds depending on the question itself. So let's put into practice these 3 steps, right, as we begin to add and subtract like surds here. Okay, so question 1a, it has 6 times square root of 2 plus 7 times the square root of 2. So over here, we can already notice that square root of 2 and square root of 2 happens in both surds in itself. So this means they are like terms, right? So we would have already satisfied step 2 over here. So looking for like surds. Before that, let me just go to step 1. So it says simplify each surd. Knowing that 2 is the very least sort of number that is not a perfect square, and that can only be times by 1 in that sense, this is the simplified surd already, right? So this is a simplified form of that. So therefore, we do not need to carry out step 1. So just jumping to step 2 where we look for like surds. So they are like surds. This means that we can add their numbers on the side together, right? So just like algebra, you're adding your coefficients. Same thing over here. You're just adding the 6, right, and the 7 together on the next time, on the next step itself. So when you go square root of 6 times square root of 2 plus 7 times square root of 2. So when you add 6 and 7, that becomes 13, and then square root of 2. Okay, so nice and easy over here. Question 1 is just locating all your simplified surds which are like surds before you begin to add the number that's just beside that. Okay, 1e. Now we have 3 of them here, and also some negative and positive numbers as well. So let's have a look. 1e, we have negative 19 times square root of 3 plus 21 square root of 3 minus 4 times square root of 3. Okay, so first up, they are already in their simplified form, so they are surds. Square root of 3 is already simplified. There's no other perfect square factors. So what this means is we can then announce that this is our like surds, right? So all have square root of 3, so they're all alike. We can then begin to add or subtract depending on what we have. Right, so we have negative 19, right? So we do this one first. Bin Mas will tell you work from your left all the way to your right. So therefore, just adding up your numbers that's just beside the surds. So we have negative 19 plus 21. Okay, so adding that up, that will be 2, okay, times square root of 3. Okay, so this is a simplified format after that. Thereafter, you can copy out, you still have minus 4 times square root of 3. Okay, so because once again, they are the same or like surds, we can then begin to subtract them. So because of the operation is subtract, so now we'll subtract them. So just subtracting the numbers that's just beside the surd itself. So that is 2 minus 4, and that will give us a negative 2 square root of 3. Okay, so nice and easy. Just be aware of your signs and also your operations, how that affects your final answer, whether it's a positive or a negative surd. Right, question 2. 2a, we have 5 times square root of 2 plus 6 times square root of 3 plus 7 times square root of 2 minus 4 times square root of 3. Right, so as what we have mentioned in terms of our steps here, simplify each surd. Having a look at each of the surds over here, we do not have any perfect squares to factor out from 2 or 3. Right, so this is already basically just simplified for us. Now on step 2, look for like surds and reorganize the expression. So looking for like surds, remember this 5 times square root of 2, basically your 5 is just like 5 lots of square root of 2. Right, so it's just like 5 groups of square root of 2, right? So looking at square roots of 2's over here, right, and also square roots of 2 on here as well. So 7 times square root of 2. These two are like surds, right? We also have another pair of like surds that is 6 times square root of 3 and 4 times square root of 3 as well. Right, so in being able to identify our like surds, we'll now reorganize our like surds together, just like what the steps had suggested. So equals 5 square root of 2 plus 7 square root of 2. Okay, and then after that, plus 6 square root of 3 minus 4 square root of 3. Okay, so in reorganizing that, we can now begin to add up our like surds. So with 5 square root of 2 plus 7 square root of 2, you're just basically adding up how many groups are there. So 5 groups of square root of 2 here plus 7 groups of square root of 2 here. So just adding up 5 and 7, that will give us 12. And then square root of 2. And then after that, subsequently simplifying 6 times square root of 3 minus 4 times square root of 3. So that will be 10 when we add up 6 and 4. And then followed by your square root of 3. Right, so this will be our answer for question 2a. Right, we can't simplify it further because the square root of 2 and square root of 3 are unlike. So therefore, we cannot simplify that. Now, question 3, this is a fill in the blank sort of thing. So as we now try to backtrack in terms of our steps and what it is actually in terms of this gap here as we plug the gaps. Right, so what this means is for, let's give it a go with 3a, right? So we have 5 square root of 2 plus, and you know that it has to add something to give you 11 square root of 2. Right, if you recall from what we've done above, remember when you add like surds together, you're just adding that number that's on the outside of your square root, and that determines how many groups there are. So there is already 5 groups of square root of 2 that they have stated up the front. How many more groups do you need to make 11 groups of square root of 2? Right, so basically in your head, you go 11 minus 5, and that gives you 6. All right, so you need 6 more groups of what sort of groups? And that is your square root of 2. Okay, so easily you can work out what is that missing third that you need to add in order for you to get that solution there. Okay, so as you work on to question 3G, let's give it a go. 3G it looks a little bit complex, but the same thing as well. Right, we have 2 groups of square root of 3 plus 4 groups of square root of 5 plus blank over there equals to 5 groups of square root of 3 plus 8 groups of square root of 5. Right, so we know that there are 2 different sets over here. One has a square root of 3, right? However many groups they have. One is the square root of 3, and then the other is the square root of 5. Right, so if we were to compare between, let's see, 4 square roots of 3, and I'll just do that in yellow, just so that I color code that and make that a little bit more obvious. Square root of 3 on the left side, right, versus that on the right side. Now there are 2 groups on the left side and 5 groups of that on the right side, right? So how many more do we need in terms of in terms of square root of 3 groups do we need to ensure that 2 groups become 5 groups? So they need to be balanced because this is an equation. Right, so thinking back, you will be able to see that you probably would have to add 3 more groups of that square root of 3. Right, so if you were to add this together, right, your 2 groups of square root of 3 plus 3 groups of square root of 3, that will give you 5 groups of square root of 3. Okay, so this has to be one of your surds in your answers as well. Now looking at the other surd, so the other surd is your square root of 5. Right, so on the left side of the equation, you have 4 groups of square root of 5, and on the right side, you have 8 groups of that square root of 5 there. Okay, so just to make it a little bit more obvious. Right, so we are missing 4 groups from the left side in comparison to 8 groups of square root of 5 on the right side. So what this means is we will have to add 4 groups of square root of 5. Right, so if you add this 4 groups initially with this additional 4 groups of square root of 5, you will get 8 groups of square roots of 5. Right, so in that sense, your answer will be 3 groups of square root of 3 plus 4 groups of square root of 5 that you will fit in here for your answer, right? So this suggests the dot, dot, dot over there. Okay, so you can do your comparison for those couple of questions and parts there. Now, question 4. 4a, let's have a look. We have square root of 12 plus square root of 27. Now, this is not a simplified surd, right? So this means we have to go back up over here in terms of our steps, right? You need to ensure before you actually work on anything, this should be simplified, right? So step 1 says simplify each surd. Okay, so we have 4a, square root of 12 plus 20 square root of 27. Now there's a perfect square factor that is within 12. So if you recall your knowledge on squares, so you have 1 square giving you 1, 2 square giving you 4, 3 square giving you 9, so on and so forth. So you can see that you can factorize out 4 from that 12 itself. So in that sense, that will be 4 times 3, that we can rewrite that for your square root of 12 here. Now for 27, you do have a perfect square factor of 9. So therefore, you can rewrite that as well, 9 times 3, square rooting the whole thing. Right, so on the next step, you can detach that square root of 4 times square root of 3 plus square root of 9 times square root of 3. Right, so simplifying that, you know that square root of 4 will give you an absolute whole number of 2. Square root of 3 plus square root of 9 gives you 3. and then followed by times square root of 3. Right, so once you have simplified that, okay, you can see that there are now like surds. So with step 2, up the top it says locate like surds or reorganize your like surds after that. So you don't have to reorganize them because there are already like surds, and that's just only what we have over here. So that's square root of 3 in terms of identifying that they are like surds. Now, so the next part is you can then proceed to add your like surds there. So just adding the number of groups together, which is 2 plus 3, giving you 5, and square root of 3. Okay, so this is an example in terms of a full scale sort of using your different steps to try and simplify your surds. Now, question 5 will be similar to question 4 as well, just that you have subtraction in there. So just be very careful of your signs as you begin to work out your surds. Now, move on to question 6 here. Right, so 6, I've just selected some couple of parts. We'll just do 6a over here. Now, we have 6a, square root of 12 plus 3 times square root of 8 minus 2 times square root of 27 plus square root of 32. Right, so the same thing, you do need to simplify your perfect your surds in itself. So you're trying to pick out your perfect square factors there. So square root of 12 can be rewritten as 4 times 3, square rooting that, plus 3, right? And the same thing as well, 8 has a perfect square factor of 4 there, right? So 4 times 2, square rooting that, minus 2. We can also factorize out the perfect squares from 27, and that is 9 times 3, 9 being your perfect square, plus, right, 32, we have 4. So 4 times 8, square rooting that. Okay. All right, so on the next step, you'll simplify that. So square root of 4 times square root of 3 plus 3 times square root of 4, square root of 2 minus 2, square root of 9 times square root of 3 plus square root of 4 times square root of 8. Okay, so now simplifying all our perfect squares there. So now we have here 3 times 2, right? Because your 2 comes from square root of 4. So therefore, in actual fact, this will become just 6. Okay, so 6 groups of square root of 2 minus, we have 2 times square root of 9 will give us 3. So 2 times 3 giving us 6, square root of 3 plus 2 square root of 8. Okay, so therefore on the next step as well, we can see that square root of 8 still has a perfect square in there. So we can proceed with also still carrying out our perfect square factorization. So equals to 2 square root of 3 plus 6 square root of 2 minus 6 square root of 3 plus 2. And then if you factorize 4 times 2, that square root there. So on the next line, you can see that that can be further factorized out. Right, so square root of 4 will become 2. So 2 times 2 giving you 4, and then square root of 2. Okay, now that we have our simplified surds over there, we can then begin to simplify that. So with square root of 3, square root of 3, these are like terms, as well as square root of 2, square root of 2, these are like terms as well. Okay, so reorganizing that to square root of 3 minus 6 square root of 3 plus 6 square root of 2 plus 4 square root of 2. Okay, so with 2 take away 6, that gives you negative 4 square root of 3 plus 10 square root of 2. Okay. Right, coming down to question 7a. All right, so let's give it a go. 7a, find the value of x if square root of 63 minus square root of 28 equals to square root of x. All right, so let's just write that out. Now, first things first, we will have to simplify each of our square roots that we have on the left and the right. There are still a couple of perfect square factors in them. So with 63, we can break that up to 9 times 7. 9 is a perfect square there. Minus square root of 28, we can do 4 times 7. Square rooting that as a whole equals to square root of x. Right, so if we were to simplify that, you can see that square root of 9 times square root of 7 minus square root of 4 times square root of 7 equals to square root of x. Right, we can then simplify square root of 9, that gives us 3, and square root of 7 minus square root of 4 gives us 2 times square root of 7 equals to square root of x. Right, so now that we have our like surds out, right, we can then begin to subtract. So subtracting the groups. So there are 3 groups over here minus 2 groups. That gives us just 1 group. So it's just square root of 7 equals square root of x. So therefore, you can see x is equals to 7. So x is on the inside of your square root. So therefore, your answer is not square root of 7, but your answer is x equals to 7, right? So just quoting that number that's within your square root itself. Right, question 8. For each rectangle, find in exact form the perimeter, area, and the length of the diagonal. Right, so 3 things that you need to find for this question. We'll just do question 8a for the purposes of this illustration. So we have 8a, right? So the first thing they ask for your perimeter. Now, we have the sides of square root of 2 and square root of 3. So this looks like it is a rectangle with both sides on the left and right being the same and the top and the bottom being the same. Right, so we know that for a perimeter of a rectangle, that is 2 times the addition of your length plus width. Right, so with that, being able to identify that this is your length and this is your width, square root of 2 being your width, that should do as well as you begin to plug those values in. Right, so as your perimeter on the next step, you will then plug in the values of your length being square root of 3 plus square root of 2 for your width. Right, if Beatmice will tell you to try to solve whatever that's in your brackets here, but unfortunately, these are not your like surds, so therefore we can't do anything for them, right? So if you're to leave in terms of your answers, you could leave it as such, right, with 2 times the sum of square root of 3 and square root of 2, or you can expand that with 2 square root of 3 plus 2 square root of 2. Okay, so either of that will be correct, right? So if they've given you units, you'll put units. In this case, there are no units, no cm, no millimeters, and what have you. Therefore, we can leave it as such. Okay, now the area of this figure here. So we know our area is equals to our length times width, right, for our rectangle. So that's a formula that we've learned since young. So with that, plugging in your values once more, L is square root of 3 times square root of 2. Okay, so applying your basic rules of your square roots there, we can then just multiply 3 and 2 on the inside of that one big square root itself. Right, simplifying that, you get square root of 6 as your area. Now, last but not least, we have our length of the diagonal. So we are looking at this diagonal that goes along here. Okay, so this will allow you to recall your knowledge on the Pythagoras theorem, right? So we know that for Pythagoras theorem, we need to identify our shorter sides, which is this, okay, square root of 2, and shorter sides, square root of 3 as well. The longer side, the diagonal side, that is your hypotenuse, so that will be C, that we'll label from there. Right, formula for Pythagoras theorem, as we know, that is the sum of the squares of both the shorter sides equals to the square of your longer side. Okay, so substituting your values in, we know that A is square root of 2 plus B is square root of 3, right? But don't forget to place your squares as well. So your squares need to be outside because that's reflected as well on the top. You do need to square your sides. Now equals to C squared. Okay, so if once we solve that, so you know that your square roots and your square will just undo each other. As you simplify that, that's just 2 plus, same thing as well, plus 3 equals to C squared. Right, so for the purposes of your unknowns being on your left side, let me just swap that around. So c squared equals to 2 plus 3. Simplifying that, c squared equals to 5. Lastly, they've only asked you to find out the length of that, the diagonal, and that's just only c that we need. So in order to remove that square on the left side, we will square root both sides, and that will be square root of 5 for our diagonal. So this will be your final answer in terms of the length of the diagonal. Right, so hopefully this video has given you a good introduction onto the different types of questions that you attempt. Please attempt all questions from questions 1 to 8 for exercise 2B, so all parts of that. So whatever that we haven't gotten done, you should be able to carry out with those couple of examples. So always remember your steps, right? Just to break it down in terms of adding and subtracting your surds, it all revolves around these couple of steps here. Just 3 short steps. Step 1, simplify each surd. Step 2, look for like surds and reorganize the expression. And step 3, adding or subtracting your like surds. Thank you.